Welcome back to my channel. I'm sorry it's been so long since I produced videos, but I'm sure those that know me understand the reasonings why. The purpose of today's video, and possibly one or two to follow, is largely about preamp. Now, I know you've heard lots of stuff from me in the past about preamps. I propose to go into the detail as to what makes a good preamp, what makes it sound good. Originally, I was just going to talk to you about it, but then I thought, well, instead of just talking about a preamp, why don't we actually build a preamp and measure the parts of the circuit that we've been talking about? We could possibly even make boards and even the finished product available to you good folks should you wish to build it. Anyway, I'm getting ahead of myself. Let's make a start and let's talk about some of the things that make or break a good preamp. The first thing is, what is a preamp? Now, the very title suggests it is an amplifier before the main amplifier. Now, this really only applies to, I hesitate to say high end, but if you like, the better end, not necessarily in price, but in sound quality. These days, with so many Class D little amplifiers that actually, well, they obviously do have a built-in preamp, otherwise there wouldn't be usually enough gain, and no power amplifier likes to be fed directly from a volume potentiometer or tone controls or anything like that. So even the nastiest of integrated amplifiers will have some form of preamp. It simply has to. There won't be enough gain otherwise. And this is often achieved these days by a single chip, something like the 5532. They use that chip because it's cheap, readily available, and one or two are actually genuine. But that's another story altogether. Let's assume that you're going to build a preamp and eventually a power amplifier. The preamp ideally should be where the gain is, and the power amplifier should have not very much gain. It tends to be becoming the norm that power amplifiers today, dare I mention the L12, sorry, for those that have been upset by previous videos on that subject, but the gain of that is really too high. The power amplifier needs to have enough gain, obviously, and typically have a sensitivity of about 1 to 2 volts RMS. So the preamp would need to have all the gain, and the main thing about the preamp is it should have a variable gain. I don't mean the volume control, because clearly every source needs volume control, but I mean the actual gain of the preamp, because you can't say one preamp fits all, because clearly when you're designing a preamp, unless you have a specific power amplifier in mind, then you can tailor it, and then it tends to be known as an integrated amplifier. But if we're looking at two separate products, you already may have a power amplifier which you're really happy with, so you just want a preamp that matches. So it's important that this preamp has a variable gain. The preamp circuitry that we're going to be talking about has a typical gain of around 2 on the minimum side and about 7 on the maximum side. Bearing in mind that these days most DACs or whatever you're going to, even Bluetooth if you really want to go that low, they're getting better. But I know that people do want to use them, and so we need to cater for such things. Now, one thing we're not going to talk about in this video is from a preamp that has a phono stage, because it's largely a separate preamplifier that would then drive this preamp, because the criteria for an RIAA preamp, which in other words will work from either a moving coil, standard moving magnet, and is beyond the scope of this particular video, although it's something, if there's enough demand for it, we may well talk about in the future. So needless to say, this preamp has no EQ, so you cannot feed a preamp, a pickup or cartridge, for want of a proper word, into this preamp. You would need a high sensitivity of about 3 millivolts or even less if you're using a moving coil. So as you can see, it's already getting messy. So let's assume that this will be covered in another video and is a completely separate topic and has more influence on the sound than any other source, because most sources these days only require amplification, nothing else. You don't want it to add anything. And the other thing we won't be talking about are filters, tone controls. Again, another topic for another time. The preamp circuitry we're going to be talking about is just that. It's designed to have no effect on the sound at all. It won't add warmth, to quote a disgustingly horrible phrase, best kept in valve circles, I think. And it will have very wide bandwidth, minuscule distortion that's virtually impossible to measure. This is the goals of the preamp we're talking about. Something that is rarely talked about is its output capabilities, because many people will say, oh, most preamps will drive a lowish impedance output, which on the face of it is actually true. But something that's virtually never mentioned is how well it will drive a capacitive load, which if you're linking it with a piece of wire, automatically it has capacitance. Maybe a few picofarad, maybe up to 100 picofarad for say a 1 meter length cable. Some amplifiers actually, well, in fact most amplifiers have a filter on the input stage. So the first thing it sees, apart from a series resistor, is a capacitor. And I keep mentioning the L12 because it's an amplifier that many people know. And out of the box, it has a huge input capacitance of around 220 picofarad, if I remember correctly. If it's wrong, I will correct it in the editing. So if you have, say, a meter of screened cable and you're feeding it into an L12, the capacitance that the preamp is going to see could be of the order of 300 picofarad, which will do havoc to the output of many chips. Let's look at a practical example. You often see a single chip preamp. eBay's full of them, and I've tested a few myself. Some of the tests that we, when I say we, I mean other people like myself, do is you put a resistive load across the output of the preamp and it all looks wonderful. But very few people, and I hold my hand up to this, is guilty of not testing it with a capacitive load, because people always assume that a preamp has a low impedance output, which is true. A good preamp will always have a very low impedance output. Most amplifiers have a medium these days. For this conversation, by the way, we're excluding valve circuits because that's a completely different ball game and requirements. So put that to one side. For the moment, we'll get there. Let's take an example of an LME 49720, which I think many of you will know is one of our favourite ICs. It offers distortion so low it's barely measurable, and very wide bandwidth, high slew rate, etc., etc. They typically quote an output as being able to drive a 600 ohm load. If all you're going to do is couple that to your power amplifier with a couple of inches of cable, that's fine. You don't need to do anything else other than use that chip. But a preamp by its nature means it's usually in a separate box and there is a cable connecting it to a power amplifier that at this stage we don't know what the input of that is, how capacitive it is, or otherwise. Generally, most power amplifiers do have quite a high capacity input impedance for two reasons. One of them is to limit the high frequency response, because these days most chip derived amplifiers naturally have a wide bandwidth. Some people believe, maybe falsely, but some people think the earth is flat. But we won't go there. I don't want to upset any of you good folks. Let's assume that you have an average or even an L12 amplifier. You have quite a lot of capacitance there, and very few of these kind of chips like a high capacitive input, and it can lead to, well, the first thing it leads to is high frequency roll-off, which aren't generally measured by reviewers, and I include myself, because I will never know what you're going to connect it to, and it's very rare you see a preamp loaded with a capacitor to simulate an amplifier. Using a single chip as a preamp is not really a very good idea unless it's part of an integrated amplifier where it sits right next to the input of your amplifier. And that's the way it's used in many of these Class D products that you see, except they usually use an inferior chip, the 5532. Now, don't get me wrong, that's not a piece of junk by any means. It's used in broadcast mixers and studios and has been for many, many years. So people that say they don't like chips in amplifier and everything should be discrete, virtually every piece of music that you ever listen to has been through at least one 5532, and in the case of mixers and things like that, possibly dozens of 5532. So you like it whether you like the idea of it or not. Anyway, I diversify. What's the answer then? Well, the answer is a buffer stage of one form or another. The buffer stage should again have a very low output impedance and should drive a capacitive load beautifully. And one such circuit to that is called a diamond stage. Among the many advantages of using this so-called diamond stage is that it can maintain the speed of the IC without, well, it doesn't slow it down. Can't make it better, but normally if you connect a capacitive load to the IC, it will slow down the actual chip speed, and it can make it ring and tail off the high frequency end. So the point of using this diamond stage is it improves the even lower drive capabilities because the output impedance is really, really low. And as I've shown you on a previous video, you can actually drive a loudspeaker from the output of the preamp. It can drive quite large capacitive loads. And I forgot to mention earlier that the maximum capacitive load that the basic LME can do is 100 picofarad. And as I've mentioned earlier, you can get that sort of capacitance in some leads that just join one to the other. So if you then couple that to the amplifier, which has a huge capacitor on the input down to ground, you could easily have 300 odd picofarad, which will make most preamps ring. And it's something that you wouldn't actually pick up on tests, because even when I've done tests, I normally put a 47k load resistor, but I don't usually add any capacitance. And when you do, the preamp can look a little nasty, overshoot on the square waves, which obviously is going to affect the dynamics of the sound and change the sound. Now, one thing you don't want to do is change the sound. A preamp, and I've said this and so have many people many times before, a preamp is just a piece of wire with gain. That's all it is. It's surprisingly hard to make it like that. You get people using the words, oh, the sound is warm. It's one of those words that to me is an excuse for adding colour to the sound. Because if you put in, let's use a practical example. If you put in the world's best recording, okay? I haven't found it yet, but if you find it, if you put that into your preamp and then you listen and measure what comes out, it should be exactly the same, but bigger. 100 millivolts in, 1 volt out. That's the job of a preamp. It shouldn't restrict the frequency response. It shouldn't add any distortion. Well, that's a silly thing to say, because there isn't any circuit on this planet that doesn't add some distortion. But when you look at the distortion of such a preamp, it's 3 or 4 noughts, 1. So effectively, it's so far down that it's lower than the actual noise level of a good preamp. So you're certainly not going to hear such low levels of distortion. And indeed 10 times more than that you're unlikely to hear. It's relatively easy to get these days low distortion. And I include intermodulation, any kinds of distortion. And it's the same with noise, with good PCB layouts. And this is also quite an important feature. The preamp does need to keep the inputs away from the outputs, and it needs to be laid out using standard good practices. But it's amazing how many on the market don't do that, and you find current cables going past the inputs and things like that, and it all leads to instability, oscillation and other sorts of problems. The next really important feature I'd like to talk to you about is negative feedback. There are as many opinions on this subject as there are hot meals in a cafe or restaurant. I can't think why I said that. It has no bearing. I might edit that out later. Anyway, I'm sure many of you have seen people, quite well-known people, as opposed to me where nobody knows me, except you do, of course. No cut, I won't say that. There are many opinions as to whether feedback is good or bad. Now, you won't be surprised to hear that I think feedback is horrendously important. And we're talking about negative feedback, of course. Positive feedback is not terribly good. That's called oscillation, amongst other things. Usually bad language, but we're going to talk about negative feedback because there won't be any positive feedback on our circuit for sure. Most transistors and integrated circuits are basically, but we'll talk about just the transistors for the moment, but they are basically a not terribly linear component. And the better the transistors, the wider the linear part of the circuitry is. But it's never that perfect. At extreme ends of the bandwidth, particularly the high end, the linearity can be quite poor. If you apply negative feedback, and providing it's in phase, or I should say it's out of phase, it will do two things. It improves linearity, it improves the bandwidth, so instead of the frequency response being like that, it's flat. And the more negative feedback you put on, theoretically and generally in practice, the better the circuitry is. But there will come a point when, if you like, one of the side effects of negative feedback is it reduces the gain. So theoretically you then need another stage to make up for that. But if you design it carefully, you want the negative feedback to be just right, and is also a way, by the way, of controlling the gain of the preamp. Because if you just use an IC or a group of transistors without feedback, it will be noisy, it will be non-linear, it will have a poor frequency response and high distortion because of all those factors. So people that advocate circuits as having no feedback are better. I don't understand that. To me, they need to go back to school and learn some theory. That's all I'm going to say. But if you believe that no negative feedback or very low negative feedback improves the circuitry, I respect your opinion. You can prove it quite easily just by measuring it. And for people that say it's not what you measure, it's what you hear, that is nonsense. Because test equipment is way more sensitive than these things. And I'm not talking about old fart ones like mine. Even if you're in your 20s, instruments, test equipment is way more sensitive. You can measure down to minus 100 and something dB. Your ears can't resolve that. But you do have to be careful with it, because if most circuits will have phase shift at the extreme edges, and the low end is less important because the ear is less sensitive anyway to low frequencies. But the high end, if the linearity and the phase shift starts to change, and instead of being completely out of phase, it starts to become a little bit in phase, that's what you call instability or oscillation. And if you feed that back into your input at very high frequencies, it can make the sound gritty, even though you can't technically hear it, and it can be as high as several megahertz. So if you do have very wide bandwidth amplification, which you do want, we'll talk about that more later, you have to make sure that the circuitry is such that it's in phase for all of your passband. And if it starts to get out of phase, you're going to have trouble. And it's extremely hard to design that out. And it can be something as simple as poor layout on your printed circuit board. But often it's incorrect value components. Clearly, negative feedback, as the term implies, means that. It doesn't mean a little bit of positive feedback, because positive feedback is called an oscillator. If I show you this document, these are my notes. It's not a script, because I never work off a script, but these are my notes on the topics I want to cover on Preamp. And I did mention earlier that it will lead to a working preamp of staggeringly high performance. I know that sounds corny, but it's true. And to prove the point, this is the board we have made. This is a blank, obviously. There already exists 3 prototypes that have been made with the circuitry we will be talking about in this. I want to whet your appetites and show you a completely working preamp with staggering figures. This has already happened. This is not something we're going to do. It already exists. I haven't put any component values on this as yet, simply because I will talk to you in a further video about the circuitry itself rather than just an ambiguous preamp. And we are also looking at the possibility of making these preamps either a board or a kit available to you good folks. But we're talking a little bit ahead, other than to say we now have prototypes working, and they've been running now for the last 6 months without issue. And in that whole time we've only changed one component. In fact, we've added a component. Well, that's the end of this first video. Thank you for watching. It's good to be back, and speak to you very soon. Bye bye for now.